Hello and a warm welcome to the Glaswelt Expert Talk. We're here in the hallowed halls of Bürkle in the beautiful sunny town of Freudenstadt. It's nice that you could join us. In our webinar, which will last about 45 minutes, we'll discuss Bürkle's Autoclave-free glass lamination and take a closer look at our centerpiece here behind me, the EasyLam IFL. We have a panel of experts here who can answer my questions. And of course, you, our viewers, will have the chance to interact with us too. So if you have any burning questions, please feel free to ask. You can also use the chat function, and your messages will come straight to me. Oh, I can see myself on the screen. So this is where your questions come in, and I'll put them to the experts on your behalf. We want to take a closer look at what happens here, but first I'd like to introduce our experts. We're joined by Robert Gaiser, Glass Sales Manager, and Daniel Klaus from Bürkle's Development Department. Hello Robert, hello Daniel. We were wondering how we could give our viewers a nice introduction to the company. And we thought maybe a film would be a good idea, followed by a talk. After that, we can take a tour of the site. It doesn't get much better than that. So now, let's roll the film. Have fun with our first trailer.
Und viel Spaß mit unserem ersten Trailer.
Those were the first impressions of our EasyLam IFL, and now we'd like to delve a bit deeper into the subject with you, our viewers. Robert, having just seen those images, my first question is, it was around 2018 that Bürkle first entered the glass market. What was it that made you want to enter the flatbed laminating market?
Well, it was actually back in the 1990s that Bürkle first entered the area of glass production with coating machines for painting and coating glass surfaces. But as you mentioned, glass lamination is an area that's quite new for us. We first entered the photovoltaic sector in 2005 with lamination solutions, and over the years, we've managed to market our systems very successfully. At some point, we were approached by new clients who were interested in our systems, especially in the field of switchable glass or smart windows, in this case, and we subsequently used our PV technology in a slightly modified form. At some point, we found ourselves working on a new project, and it became clear to us that we couldn't make any progress with the existing technology, so we decided to develop something new. We already had the ideas in our heads, and were then able to put them into practice. After that, we realized that this technology is perfectly suited for VSG or laminated glass in general, so we're definitely going to be more active in that area.
So that's when it all took off. We can see you're passionate about what you do. We were just chatting and taking a look at the installation, and you really seem to enjoy it here. How's the system constructed in detail? We've just seen the images, but maybe you could give us some technical details.
In principle, the system consists of 5 components. At the first stage, we have an in-feed area where the batch is put together. But unlike conventional lamination in an autoclave, the individual products or sheets are transported into the system horizontally. That means we don't have to manually lay them in the system using a rack, but instead they are transported to the in-feed bed automatically. That's where we put the batch together at the beginning. That is, the individual products are prepared. When the products are ready to go, you press a button and they're conveyed into the system and undergo the first lamination stage. In this stage, we have a vacuum press for temperature and pressure. This removes the residual air between the layers. Then we generate contact with the heating plates. This provides heat transfer, and we can then carry out the lamination under pressure. After a certain time, depending on the product, the complete batch is conveyed to the next stage, where we have a further heating press, and then the lamination is completed. In the next step, the products are taken into a cooling press, where they are cooled down again. After that, they are taken to their final position on the outfeed conveyor. By that time, after going through the cooling press, they have a temperature of less than 30 degrees Celsius. This allows us to process the products directly, and then they are either immediately transported to the next stage or removed and manually taken to the next stage or the next production process.
That's fascinating. We've saved a bit of time, and we'll talk about that in a moment. Daniel, you're responsible for the development of lamination systems at Bürkle and can look back on quite a history as a member of the team. What was the crucial point with the EasyLam IFL? After all, you can't just shake an installation like that out of your sleeve.
Ja, Dorothee, ich muss sagen,
well, Dorothy, I have to say, it wasn't easy to build up this system here and to market it afterwards. As we mentioned earlier, it all began with photovoltaics. We started laminating glass with EVA films and cells, in other words, classic glass foil modules.
Ein ganz klassisches Glasfolienmodul.
Over time, there was increasing demand for a glass-glass module, in which the rear side is augmented with an additional sheet of glass. That's when it became clear to us that the process of using membranes would eventually come to an end. We had some ideas, and we also looked at other processes, autoclave technologies, hotbox, and other approaches we could use.
Autoclave-Technologien, Hotbox oder irgendwelche Sachen, wo man da einbringen kann. Letztlich,
in the end, we took a completely different route, and we're now proud to be able to show you this system. The situation now is that in the first stage, we have 2 plates that pass the contact heat into the product, applying the greatest heat input that's physically possible, which significantly shortens the entire process.
Und der Prozess ist am kürzesten.
Let's talk about the layup of the product, because every glass manufacturer has a different product layup, different formats, different laminating films, and so on. And in terms of the laminating foils in particular, there are some major differences. How can we solve this problem and meet these challenges?
We can draw on our many years of experience in the solar sector. There are EFA films used in that sector which are 90% as standard. In the meantime, other films, such as polyolefins or ionomers, have become available for use in the industry. So we've been able to transfer our expertise in using these films directly from the photovoltaic industry. In the glass sector, PVB film is certainly a product we need to investigate, and Sentry glass is another. The first photovoltaic modules also contained PVB film as a laminating film, so we've already gained a lot of experience with it. Now that we've gone into production with our IFL process, we're gaining new insights every day. So now we can laminate process-safe glass for PVB films and Sentry glass films.
Daniel, what about asymmetrical layups? I imagine that to be particularly complex.
Ja, nochmal zum Thema.
When we talk about asymmetrical layups, it means we use different thicknesses of glass. A standard glass unit usually consists of either 3 3mm or 2 3mm sheets of glass. An asymmetrical unit has a thinner and a thicker glass element, and we have already successfully tried using 6mm thick glass on one side and 1mm glass on the other side. The main problem here is that the glass gets stressed when it is laminated, either during the lamination itself or at the latest when it cools down. The different glass elements can also expand differently, and then there's a risk that the glass could buckle. But in the process we use, there is contact with the product in every stage. In both stage 1 and stage 2, we have heating presses, so we can run the heating plates at different temperatures, and therefore prevent buckling and stress in the glass. A crucial aspect is the cooling phase. In our system, we can set the temperature individually. For example, the lower plate might be at 20 degrees Celsius, while the upper plate is at 60 or 80 degrees Celsius, depending on the product layup. That way, we can ensure that the glass sheets don't buckle.
Yes, that's a definite advantage. Thank you, Daniel. Robert, having just heard that, I can imagine that Bürkle is facing new customer demands. Since every glass layup has its own laminating recipe, it's not really feasible for you to store the entire portfolio or product range of the market in a database. Or is that possible after all? How do you deal with it?
Wie macht ihr das? Oder geht es vielleicht doch?
Of course, it would be difficult to cover the whole market. We still have work to do there. But we've already started to map the product portfolio of our customers. So when we start on a project, we discuss which products they need, and we then develop the best possible solutions together with the customer. The issue of speed is always important, but also stability, of course. And these solutions are then stored in the HMI of the laminator and can be accessed at any time. Theoretically, they can also be accessed via interfaces. But as a rule, we try to develop recipes that can map as many different product layups as possible. Then you don't have to change recipes so often. That makes it a bit simpler, and it can also be mapped very well.
What size system formats do you currently offer, and in what thicknesses?
The formats in our current portfolio are in the following sizes. First, we have a usable area of 1.6 meters by 3.2 meters. Then there is the system size of 2.1 by 4.2 meters. And then there's the large system, which we would like to show you today, which has a usable area of 2.6 by 5 meters. We're currently looking into offering jumbo sizes, which would be 3.2 meters by 6 meters, for example. So if a customer request comes our way, we will definitely explore those possibilities. You also mentioned the product thickness. We designed the systems so that they have a chamber height of 25 millimeters as standard. That means the maximum product thickness would be 25 millimeters. But we've already discussed with interested parties whether thicker layups are possible or multiple layers, such as 3-layer glass or 2-layer PVB, which we have already laminated. But if we go beyond a thickness of 25 millimeters, we'll have to raise the chamber height, which is possible if you change a few features. The system could also be converted to that size later on, so we are well prepared for processing thicker layups.
Super.
Great. Now, let's go back to the actual production process. With flat presses, it's not normally possible to produce different thicknesses in a single batch because there's no contact with the press surface. How can we solve that issue? Do we have to pre-sort in those situations? And there are also challenges such as solar control glass. That's going to be the next topic. But how do we manage to solve that?
You're absolutely right. Let me explain it in simple terms. In a flat press, if we have a thick product at the infeed and outfeed, for example, and a thin product in the middle, then the plate cannot form a contact in the middle, which means there's no heat transfer and we can't laminate the product. That's why we carry out pre-sorting, so that we always have the same product thickness in a single batch.
Das heißt quasi in der Charge müssen wir immer die gleiche Produktdicke haben.
We're currently in talks with various software manufacturers who offer complete glass production planning solutions, which includes pre-sorting of the products. This is already being done in the area of cutting systems. It's also done in tempering furnaces for glass, where you need to pre-sort the glass on the basis of its thickness.
Für Glas muss man letztendlich auch anhand von den Dicken der Gläser vorsortieren. Und
we hope that in the future, if it can be realized, we will be able to cut the glass at the beginning, process the edges accordingly, and perhaps cut any necessary holes. Then it would be conveyed into the tempering furnace, then onto the laminator. It is assembled before the laminator, and we wouldn't have to interrupt each step of the process to put together the batches on rack trolleys, for which we then have to plan the logistics. Instead of all that, we could realize a production line and integrate the system in-line. By the way, that's what IFL stands for, inline flat lamination. That's our vision for the future.
So you could call it simplified logistics. Okay. Daniel, in the middle of this year, the VSG pre-construction tests were scheduled, and our end products were put through their paces. You attended these tests together with your team. Bürkle was able to pass the DIN 12543 and 12600 tests with an incredible lamination time of 11 minutes per cycle, which is really great. Which product layouts did you use in the test, and which ones can we currently use? And what about low E and solar control glass? That's different again.
Yes, that's right. I'll answer each one in turn.
Yes, just like the machines. And hopefully we'll answer our viewers' questions like that too. They're arriving here on my phone, and I'll put them to the experts when we're through here.
So the first question was about the DIN standard and pre-construction test. We used two 3mm sheets of glass to carry out the tests with a PVB film that was 0.76 millimeters thick. We laminated the glass in our laboratory and sent it to the test center in Darmstadt, where it was put through all the tests. And we're proud to say that we passed all the tests, because that was one of the biggest challenges. Up to that point, people had always said that flatbed laminating doesn't work, and that there might be difficulties when it came to testing. But we passed the test. Your next question was about low E glass and all the coatings that are currently applied to glass. Up to now, we haven't had any problems in our process in the area of solar radiation, where the light is simply reflected. That's because we use contact heating. With other processes, such as those that use IR emitters, it can be a bit tricky in some applications. If you apply coatings that don't allow IR rays to pass through, you can't achieve temperatures in the range that you need. So in our process, we don't have any problems with coatings.
Also somit muss ich sagen, haben wir keinerlei Schwierigkeiten mit Beschichtungen.
I always mention this subject, and if we have a customer who wants a special coating, we can offer to carry out tests in our laboratory. It has a test area of 1 by 2 meters, where we can carry out experiments and tests directly on our premises, and analyze the results later on. But right now, we consider this quite feasible.
Durchaus machbar alles.
Excellent. Thank you, Daniel. Robert, if someone is watching now and says, I could imagine integrating this system into ours, I'd like to connect the whole thing, what would your answer be to that?
Yeah, my first reaction would be, great idea, sure.
Exactly.
We usually start out by having a chat. We talk about which products the interested client would like to use, which sizes, which layups, and the volume. After that, we move on to the conceptual design. I mentioned earlier the sizes that are available for the system. Then we can define which system size makes sense for the customer's production capacity. And eventually, we can begin the planning phase. We generally like to look at the existing conditions on the site to see how it can be integrated. The best option is usually to integrate the whole thing into the existing line. After the layup of the products, the pre-nip stage would then be bypassed. Our in-feed conveyor would then be located in the climate-controlled chamber, and the system would be placed behind the layup area. That way we can integrate it, then start planning in more detail in collaboration with the customer.
If you have any questions or have any ideas, these guys are the best people to talk to. You can find their contact details here on the events page or on our website. Anyway, I'm a typical Swabian, and I admit that I like to save money. So let's talk about savings compared to autoclave manufacturing. Where exactly can we make savings?
Wo genau sparen wir?
We're Swabian too. That's one of our favorite subjects as well.
Yes, but today we're speaking High German.
Well, we're trying. But we can't hide the accent completely.
So how do we make savings? More importantly, how do we save and where?
Ultimately, we divide the whole thing into production-related costs and energy costs. Nowadays, energy inevitably includes the issue of the environment, or the CO2 footprint, so we have certain advantages in that respect. Let's begin with the subject of energy. The first system we deliver to a normal glass production plant has integrated power usage measuring equipment. That means that the energy consumption is constantly tracked throughout the production process. That allows us to calculate how much energy the laminator uses to laminate 1 square meter of product for a specific construction. Then we compared these values with values directly from the market, which our partners provided to us. The early indications show that in the lamination stage, we can save 60% more energy compared to pre-lamination with an autoclave, which is of course a huge saving.
Yes, that's a lot.
Super.
Then there's the issue of production-related costs. We have an advantage there because of our high degree of automation, which lowers the cost for preparing batches and disassembling the batches after autoclaving. Based on what our customers from the USA tell us, we could save as much as 40% in the front area, where the productions are assembled. If you also automate after the laminator stage, you can save another 40%. So savings of up to 80% are possible. If the products have to be removed manually at the back end, there's still the option of going offline again. But the potential is there, and that's how we can make savings.
It sounds like you can offer a very individual solution that can be adapted to the customer's requirements. I would first like to thank you, Daniel, and you too, Robert, for your insights. And now we have another short film for you, ladies and gentlemen. And after that, we'll really get down to business, because we're going to take a closer look at the system with our colleague, Manuel. So, roll the film and see you in a moment. Welcome back. I'd like to introduce you to Manuel Höß, project manager for glass at Bürkle. Hello, Manuel.
Hello, Doro.
So here we are at the center of our Easy Lam IFL, right at the infeed area. First, we'd like to talk about what's going to happen to it. At the moment it's in Freudenstadt, but soon it's going to move on. Where's it going to?
Yes, right now it's still here, and soon it will be put into operation. That means the mechanical and electrical installation is almost complete. After that, it will be going to the USA around early to mid-January. And we expect it to be ready for production on site by mid-March.
Ready for production then vor Ort sind.
Okay.
How exciting! It's going across the pond. I'm sure the viewers are curious to know what this machine will be producing.
The customer for this machine plans to laminate hurricane glass, and they will also produce in a wide variety of formats. This system offers the possibility to run a maximum product size of 2.6 meters by 5 meters on the bed, but it can also accommodate smaller products of 60 by 60 centimeters, for example. This is how it will work in principle. Here you see the infeed conveyor. The batch is put together line by line. This is where the operator will stand, and it's their job to put the batch together. Then each product is fed in on the ball rollers, and they build up line by line. When it's complete, we have the camera system here.
Exactly. Very important. The watchful eyes up there.
The operator then has the opportunity to check the batch. Next, he presses check, and the camera system determines whether the layout is correct and whether the gap between the products is right, because it's important to comply with the recommendations. If something is wrong, he gets an immediate alert telling him where the problem is on the batch. He can easily adjust the layout on the ball rollers, and then he gets the machine to check the whole thing again before it goes into the laminator.
Dann lässt das Ganze nochmal prüfen und ist dann bereit, dass in den Laminator dann reinfahren kann. Und vom Prinzip her kann man
In principle, we can say that with this format and this process, we can run about 900 square meters per day. That translates into an annual production throughput of around 320,000 square meters.
320.000 Quadratmeter bedeuten würde.
So this is the first step, and now we'll move on to the next one, the first lamination step.
That's right.
So we'll have to take a stroll in this direction, and I hope our camera team doesn't stumble because there's a lot going on here. There's a lot of equipment around us. But we want to show you what's happening here. So let's open the flaps so our viewers can get a good look inside. And that's the third one. All right, now all the windows are open. Manuel, what can we see here? Lamination phase number 1.
Laminationsphase Numero 1.
That's right. This is basically the heart of the system. Heating press number 1. The most important steps in the process happen inside this chamber. It has an upper heating plate and a lower heating plate, which provide direct contact with the product. And once they are in contact, the direct heating process can begin.
Die obere Heizplatte und unten die untere Heizplatte, die da drin ist. Und da haben wir dann sozusagen nachher den direkten Kontakt mit unserem Produkt und können somit mit den direkten Wärmeeintrag ins Produkt beginnen.
It has a pin-up system too.
Yes, correct.
Can you tell us about that?
We installed the pins in the lower heating plate, and they can be controlled pneumatically. When the product is fed in, the pins are already raised, and that makes it possible, as I mentioned earlier, to avoid direct heat contact from below, as long as the air is being evacuated.
Einfluss von der Hitze von unten noch vermeiden, solange wir evakuieren.
After that, when the press is closed, we lower the pins, and that allows the contact heat into the product from both sides.
Die Kontaktwärme ins Produkt einbringen.
How are the glasses transported after that? Is there a conveyor belt? I'll take a look.
The conveyor belt isn't fitted here yet. We'll be doing that in the final stage. But it will have a continuous transport system, which means the products will be laid on here and always travel on the same conveyor belt through every lamination stage. That ensures that the positioning is always right, that it is properly coordinated through every stage.
Sichergestellt, dass die Positionen passen und dass es entsprechend eben abgestimmt ist mit von allen Stufen her.
Okay, so that's the first lamination step. Is there anything we haven't covered, or can we move on to the next step?
I think we've covered the most important points.
Otherwise, please ask, ladies and gentlemen. We're moving on to the second lamination step, which is the heating press. Why did you add a second heating press in between?
Heating press 2 is basically there to allow for much higher throughput. It allows us to divide the process step, so we can run the cycle in the second step. We cut the process in half, and can thus generate more output.
Den Takt fahren und halbieren den Prozess und können einfach so mehr Output generieren.
Once the vacuum process is completed and the product is pre-laminated, all we have to do after that is to apply heat again and finish laminating the product.
Dann fertig laminieren.
But the product isn't finished until it's cooled down, so now we have to go to the next step, the cold press. This is where the glass is cooled, so join us as we wander along a bit further. So, there they are, up ahead. What can you tell us, Manuel?
Die Kühlpresse.
The cooling press is very similar in design to the heating press number 2. Once again, there is direct contact with the product, but this time it is cooled. After lamination, we need to bring the temperature down in a controlled way so that stress to the glass can be minimized. The cooling ensures that the glass is ready for further processing after the lamination is complete. It's important that the glass can be handled directly and processed further without anyone getting burned.
Bereit machen für die Weiterverarbeitung, beziehungsweise dass man sie direkt dann auch nachher berühren kann und direkt weiterverarbeiten kann, ohne irgendwelche Verbrennungen oder sonstige.
So you save more time in the cooling process. That's fantastic. Thank you very much for an interesting tour of the EasyLam IFL. We're now going to the front again to see what questions have been sent in by our viewers. If you haven't sent any questions yet, there's still some time left before I join the panel again. Thank you very much, Manuel. See you in a moment.
Bis gleich.
Welcome back. A few questions have come in, and I can hear myself twice, so I'll just turn this off. Well, now we know that the live stream is working here in Freudenstadt. Guys, I hope you're ready. The first question is, what is the cycle time for a layup of 6mm float glass, 0.76mm PVB film, and 6mm float glass? Who wants to answer?
An wen darf ich die stellen? Robert, Daniel.
I think we should pass that to Daniel. It's his specialist area.
This is another question about the process, so I'll be happy to answer. As we mentioned earlier, we used 2 sheets of 3mm glass for the certification. The layup was 3mm, 0.76mm PVB, and then another sheet of 3mm again. The process time was about 11 minutes. At the moment, we have a rule of thumb calculation in which we add 1 minute per millimeter. In the case of 2 times 6mm glass, it will be twice as thick, so you can expect a time of around 16 to 18 minutes. So 2 times 6mm can be laminated in under 20 minutes.
Da ergänze ich vielleicht noch mal.
I'd like to add something in case the next question comes up. As far as cycle times are concerned, it's better if production runs are adapted to our process. In a production sequence, it doesn't make sense to run a batch of 2 by 3 millimeters, then 2 by 6 millimeters, then 2 by 3 millimeters again, then 2 by 6 millimeters again. You have to bundle it together and run the 3mm glass in the first shift in the morning, then the 4mm, 5mm, or 6mm glass, because then the cycle times are longer.
Weil einfach die Taktzeiten sich dann verlängern.
As Robert mentioned earlier, of course we are striving to realize a process that covers as much of the product portfolio as possible. But at some point we will no longer be able to do that, and that's simply due to physics. But we are always interested in making ongoing production adaptations for a changing market.
Wo wir letztlich auch gerne unterstützen und da mitmachen.
Vielen Dank.
Thank you. Here's a question about cleaning. How's the glass cleaned before laminating?
I'd be happy to answer that. As a rule, it's exactly the same as with autoclave lamination. The processes before the layup are the same as in an autoclave. That is, the glass is usually cleaned in a washing system. But there's another interesting point I should mention. Since you asked about the tests we did last summer, we didn't have all the equipment to wash everything perfectly, so we cleaned the glass by hand using isopropyl alcohol. We didn't even have the products in a climate-controlled chamber at that time, because we don't have one at our technical center. So we assembled and laminated the products and passed the tests under those conditions, which perhaps demonstrates that we have a very stable lamination process that will allow us to produce very wide process windows.
Stabile Prozesse geht in der Lamination, wo man wirklich sehr breite Prozessfenster erzeugen kann.
Vielen Dank.
Thank you very much. Here's a question about acoustic foils. Can they be processed as well, specifically SC foils?
Ja, dann
Once again, we're talking about the process. I tend to say yes, because we work closely with PVB manufacturers and with film manufacturers in general. Even though the foils can vary in thickness, in the end, the type of film used, the layup itself, doesn't really affect us when it comes to laminating.
Aber letztlich, sage ich mal, zusammen die Mixtur an sich nachher, die tut uns beim Laminieren, sag ich mal, in Anführungszeichen nicht so weh. Wir sind da relativ.
Our process covers a very broad spectrum, so we can cover all that. So as a general rule, we can say that it's not a problem at all.
I'd like to add something here. Ultimately, we can say that as long as the film is thermally active in some form, either as a cross-linked film or a thermoplastic film, we can run it in the laminator. Of course, it always depends on different temperatures, different dwell times, and so on. Those are the recipe parameters that we've already mentioned. But basically, we can run most films that are thermally active in some form.
Dann können wir die auch fahren.
Ist das möglich?
So it's possible. Excellent.
If I may, if I could just add something.
We have time. Hopefully our viewers at home or in their home offices as
I
well.
did mention it at the beginning, but maybe the viewer has only joined us just now. Here at our technical center, we have lab machines that are perfect for testing things like that. The customer can send us the exact material they need. They're also welcome to be present during the laminating tests, or we can laminate it, make a short video, and send it to them. Then they can do their own tests, and that's it.
Great. Customers can try it out.
Yes, certainly.
Great. Now to the next question. Are there plans to fit an optical quality control device, such as a scanner for the finished VSG behind the cooling press?
I'd be happy to answer that. It's a very good question, because the system seems to lend itself to something like that. We have products in a horizontal conveyor. Quality checking is becoming an increasingly important topic for laminated safety glass manufacturers, as we've discovered in many discussions. We don't currently offer inspection in our system, but we've already held the first talks because in principle, we could integrate an inspection stage into the outfeed conveyor. The products could be checked on the bed or even with line scan cameras as they pass through the conveyor. That would mean we would have integrated quality assurance in the production line.
Produkte durchführen und dann hat man auch gleich eine Qualitätssicherung in der Produktion drin, völlig integriert.
Es sind viele Fragen reingekommen.
We've had plenty of viewers' questions. Thank you for that. The next question is, are laminates possible using PC layers or plexiglass composites? And what thickness will be possible for laminates in the future? Up till now, it's been 25 millimeters.
I think that's a question for me again.
We're playing ping pong here. It's almost as if we'd planned it.
Ja, das wird so passen.
Daniel.
Ja, also es ist so.
With plexiglass, you reach a temperature limit at some point. Way back, we carried out experiments in that direction. In the early days of photovoltaics, people wanted to stick everything they could find in the backside of the panel. And we also explored the uses of plexiglass. But it must be said that the process times are significantly longer because you need to operate at lower temperatures. And of course, you have to melt the thermoplastic, the PVB film. So actually, it's quite a simple matter. If you lower the temperature, you have to extend the time. But it is feasible.
Und ich muss es natürlich schaffen, den Thermoplast, was drin sein wird, die PVB-Folie oder was es ist, muss ich aufschmelzen. Also ist es eine ganz einfache Sache. Ich gehe mit der Temperatur runter, muss ich mit der Zeit lang machen. Aber durchaus denkbar.
But of course the question is, what happens in the long term when you laminate glass together with a plexiglass film? Perhaps there are applications for that. But as I said, that's a subject for our lab in the technical center.
In other words, try it out. Thank you, Daniel. We have a question from someone who probably just watched our tour of the system. He asks, what material are the mats at the top and bottom made of? Do they contain silicone?
Nein, die sind nicht silikonhaltig, das kann ich gleich dazu sagen.
No, they don't contain silicon. I can tell you that right away. We have heating plates made of steel in the system. The reason is that steel is a material that has a very high thermal capacity. When the cold product enters the laminator, we need to get a lot of energy into it, so we need a material with a high thermal capacity. But the steel does not come into direct contact with the products. We have the transport system in between, which is not yet installed here, which comprises conveyor belts with PTFE-coated aramid belts. So that means that we don't have any silicone or anything similar that could come into contact with the glass and leave marks, or which could then cause problems in subsequent processes, like bonding and so on. So in this form, the system is silicon-free.
Dann Probleme bekommen kann durch irgendwelche späteren Prozesse, Verklebungen oder Ähnliches. Also das System, können wir eigentlich sagen, ist in der Form silikonfrei.
Alles klar.
Okay, what about general cleanliness and cleaning the conveyor belts, especially when it comes to film residues?
Kann ich was dazu sagen?
Can I say something? Yeah? Or are you following a certain system?
Well, that's just how the questions come in.
It's all good. It's all good. Okay. When we run a process, the goal is to have as little residue as possible. That's Daniel's specialty, and maybe he'll want to add something in a moment. If there is any dirt or residue, which can always occur in some form, we make sure that the PVB, which is a thermoplastic material, is cold before we try to remove it. The system is fitted out with a brushing mechanism. The conveyor goes through all 3 presses, and then under the presses back to the front again, where the brushing mechanism cleans the conveyor belts. I mentioned before that the belts are PTFE, or Teflon coated, which means very little residue gets stuck to them.
As Robert has said, I have something to add here. First of all, as Robert mentioned, you have to ensure that you don't let anything spill out. We haven't quite got a setup in place for this yet, but our goal is to cut the PVB more or less flush before it goes into our laminator, and it should not change much after that. You don't want it to squeeze out, nor do you want it to shrink back in.
An diesem Zustand sollte sich nicht viel ändern. Also sprich, ich möchte weder, dass es rausquillt, noch möchte ich, dass er zurückschrumpft.
And we currently have some ideas and approaches to optimize that procedure. As we said at the beginning, our first production installation is already on site, and we have the possibility to implement something like that there. But our first priority is to ensure that it doesn't squeeze out in the first place, so that cleaning isn't necessary. But of course, if it gets dirty, we will clean it again.
Okay. Should the EasyLam IFL infeed be located in the clean room?
Kann ich noch mal was dazu sagen?
I can add something here. Up to now, we've implemented our systems so that the infeed is located in the clean room, that is, in the climatic chamber under controlled climatic conditions. The main reason for this is that ideally, the batch is prepared relatively quickly, and while the products are laying on the infeed conveyor, it takes a while until the press is ready or until the cycle is finished. We mentioned a cycle time of around 11 minutes or even 17 to 18 minutes. If you position the products within 10 minutes, they'll be waiting there for another 7 to 8 minutes, so it's advantageous to have them waiting under controlled conditions. That's why we are currently implementing it this way.
Und deswegen realisieren wir es aktuell auch so.
Okay. Wie sieht die
How's the transfer from the layup to the EasyLam IFL carried out?
Ja, dann,
Yes, I'd like to say something again.
Also ich denke,
Manuel mentioned it earlier when you were at the infeed conveyor. In our concept, an operator will be stationed about halfway along the infeed conveyor. They will then manually place the laid-up sheets onto a ball roller conveyor. That is set up like a matrix, and the operator loads the infeed conveyor line by line. And in the course of the next step, the camera system we mentioned before monitors the layout. It checks how many square meters are occupied, the spacing between the products, and ensures the distance to the edge is correct. That's also part of the process, and it's checked by the camera system. But as I said, there's an operator at the front who manually lays out the products. Another thing I should point out is that if you can coordinate production so that enough material comes at the front, the operator will not be a bottleneck, because they can easily manage to lay out the bed in 5 to 7 minutes. Even if they then have to correct something, it's possible in that amount of time.
So abstimmen kann, dass genug Material von vorne kommt, ist der Engpass nicht der Bediener, weil er schafft es locker, dieses Bett in, ja, ich sage jetzt mal, zwischen 5 und 7 Minuten zu legen. Selbst wenn er da noch eingreifen muss und irgendwas korrigieren muss, schafft er das in 5 bis 7 Minuten.
Okay.
This will be the last question for now. Unless another one comes in, I'll just check with my colleagues. Does the glass need to be paired after lamination?
Do you want to answer again?
Yes, I can start. I think they mean trimmed.
It says here paired.
Paired? Well, we actually do both things.
Yeah, exactly.
The answer is yes, no matter. The answer is always yes.
What we mean by trimming is that if the PVB film swells out too far, you have to cut it off and make sure it's a clean edge. As I mentioned before, we're working on keeping this to a minimum. Of course, there are subsequent steps where it has to be cut off exactly, so then you have to trim it.
Geschnitten werden muss, dann muss man das besäumen.
As for cleanliness in general, if the sheet comes in clean at the front, it will come out clean at the back.
That means no.
That means no.
So they don't need to be cleaned after all. Okay, now I have another question if nothing else comes in. It looks like we're almost finished here. If people want to visit your installation, to take a look inside and get an impression for themselves, how can they do that and where?
Ja, letztendlich haben wir...
So far, we have realized a few systems. So perhaps I'll briefly go into that first. Earlier on, I spoke about the first system, where we designed the whole thing, which we sometimes call the pilot series, the prototype, and that's located in Europe. Then we realized an installation in Florida, in the USA, plus another lab installation like the one we have in our technical center. That's located at a glass manufacturing plant in the USA as well. And you can arrange with the customers to visit those installations. But right now, there's an opportunity to see the installation here at our site.
And beautiful Freudenstadt.
That's right. You can combine it with a trip to the Black Forest. The installation is still here for the moment, and as Manuel mentioned, it's about to go into operation.
Until March, I think he said.
Yeah, exactly. In the end, the installation first becomes interesting when something is moving and something is happening. And we want to show that. It's not just about showing the machine. We want to show the process too. And in our current plan, we've scheduled weeks 50 and 51 for people to come and view the installation. There's been a very high demand, and we've already planned a few trials with interested clients. And if anyone else is interested, please contact us soon, because the demand is high, and we're quite limited in how we can plan the whole thing afterwards. We make individual appointments for people to view the installation, and that makes it easier if someone wants to run trials, so we can do that and plan accordingly. And there's also an opportunity to visit our installation in the new year, where you can get to see the process in our technical center. It's not a full-size unit, like in a production installation, but you can run the same trials, and above all, if we laminate something in the technical center, we can transfer those processes to a project or a production installation later. That's very important for our customers.
Projekt auf eine Produktionsmaschine, was natürlich wichtig ist für unsere Kunden dann, dass sie das auch umsetzen können bei sich.
I hope your mailbox is overflowing. Our viewers can find all the contact details here on the event page or on our website at www.bürkle.tech. We look forward to hearing from you. I'd like to say a big thank you to Robert, Daniel, and also to Manuel, who gave us a tour of the installation, and also to the whole team, and of course to Glaswelt, who made this webinar possible. We hope to see you here in Freudenstadt. It's beautiful here, and as I said, the installation is still on site. You're welcome to come and see it in person. Thank you very much for joining us, wherever you are. Goodbye from Freudenstadt.
Tschüss aus Freudenstadt. Tschüss.
Tschüss.
Tschüss.